KCET 2025 aspirants, so welcome to KCET Master Stroke series, and in today's we are going to do one short revision of the chapter alcohols, phenols and ethers. I can guarantee you that you can watch this one video and complete the entire syllabus. You can make your short notes, your flow charts, everything that is important in this chapter will be discussed here, okay? Starting from the preparation methods, chemical reactions, even the commercial alcohols, everything I'll discuss with some important questions as well. So please stay tuned and watch the complete video. And I also want you to sit with a notebook and a pen so that you can make the flow charts with me, okay? Because in organic chemistry it is very important to make the flow charts for the revision of the reaction, okay? So yes, let's proceed and let me tell you what all things are there. So, say whenever you study the chapter, right, you should have a clear picture of that, what is there in this. So, similarly, in this chapter, you have to think that there are 4 parts in which this chapter can be divided. The first part is very basic, in which we are going to talk about the classification, nomenclature and structure. Now, classification is very much similar to your haloalkanes and haloarenes classification. So, you won't take much time in this, it is very easy to grasp it. Next, coming to part 2, where we are going to study preparation of alcohols, preparation of phenols and the physical properties of alcohols. Okay, here some of the reactions are there which you already know. Some of the reactions will be new, and preparation of phenols will be something completely new for us. Now coming to part number 3, that is chemical reactions of alcohols, chemical reactions of phenols. So that is also very much similar to haloarenes, not much difficult, but yes, somewhat some different concepts are also used. Next we have commercial alcohols. Here also some questions are asked, we'll discuss, and then ethers. Okay, in ethers this is a very small topic as well as very important topic, so we will discuss about ether here. Okay, so let's move and see the first thing, that is your weightage. So you can easily expect like 3 questions, but from this year onwards I expect 4 to 5 questions from this chapter. Okay, so you have to study this chapter properly. So in part 1 we are going to do classification, nomenclature and structure. Okay, so yes, coming to classification. So the first classification is based on the number of OH groups. You remember in haloalkanes and haloarenes also we have a classification and in which we discussed on the basis of number of halogen groups, right? Now coming to next one, that is your sp3 COH bond. Okay, so the carbon to which the OH is bonded, if this carbon is sp3, then what all categories are there? In that the first one, alkyl alcohol, that is your primary, secondary and tertiary, allylic and benzylic, very much similar to the previous lecture. sp2 you have vinylic and phenols. Okay, so let us see here. So if you have 1 OH group monohydrate, 2 OH group dihydric and 3 OH group, it is called trihydric. Okay, next coming to sp3 carbon. So this carbon is your, one second, yes, this carbon is having OH group, so it is what? sp3 carbon. Now this carbon is attached to only one other carbon, so it is primary. Now this is your sp3 carbon which is having the OH group, it is attached to 2 other carbons, so it is secondary. This is attached to 3 other carbons, so it is tertiary. Okay, that is the first thing. Next, talking about allylic alcohols. So in allylic alcohols what we have, if you see here, this is the carbon, okay, which contains the OH group is present next to the carbon having double bond. Okay, that is your allylic. Similarly, you have here this carbon, this allylic carbon can be primary, secondary and tertiary, but it is always allylic. Now coming to benzylic, benzylic is also the carbon which is attached to benzene ring, to that OH group is attached. Okay, that is called primary. So benzylic can also be primary, benzylic can also be secondary, benzylic can also be tertiary. Okay, fine. Next we'll move to vinylic alcohols. So in vinylic alcohols what happens, the carbon which is having the OH group is directly attached to the double bond, so it is your vinylic carbon. Okay, carbon having the OH group should be directly bonded to a double bonded carbon. Next, in phenols you have the same thing, but it is in the benzene ring. Okay, so this is called your monohydric. You can see 1 OH group, you have 2 OH group dihydric, you have 3 OH group trihydrate. Okay, these are all classifications. Okay, next coming to ethers. Ethers are of two types, symmetrical and asymmetrical. So up in the both side of ethers, see, these are the two sides of ether, right? On the two sides of ether, if the groups are same, then it is called symmetrical ethers, and if on the two sides of the the groups are different, then it is called asymmetrical ethers. Okay, now once we have understood these concepts, let us try to solve some questions. Okay, quickly. So you have to identify whether it is primary, secondary or tertiary alcohol. So you see this carbon is containing the OH group, and this is directly attached to only one carbon, so it is definitely primary. Now you see here, this carbon is containing the OH group and this is directly attached to one carbon, so this is also primary. This carbon is containing the OH group, it is attached to one carbon, so primary. Now this carbon is containing the OH group and this is attached to two carbons, so it is secondary. So next one, we have this carbon containing the OH group, it has two carbons, so it is again secondary. And if you see this carbon which contains the OH group, it is attached to three carbons, so it is tertiary. Okay, so that is how you can decide. Next, moving forward to nomenclature. So common names are much more important, and you know in nomenclature the suffix will be OL attached. Okay, that is for all the alcohols. So you can see here this propyl group is plain propyl group is there, so it is N-propyl alcohol. Next you have this one propane 2-OL, or you can say isopropyl alcohol. N-butyl alcohol, secondary butyl alcohol, this is what you can see isobutyl alcohol. This group is isobutyl group. Okay, next you have tertiary butyl alcohol. Then this is important here, when you have two CH2 group and OH, that is called ethylene glycol. Okay, and when you have 3 CH and OH group, that is called glycerol. Okay, glycerol and ethylene glycol. Okay. Next, this is very important, this I am telling you again, please mark this and draw this diagram for this common name of OH groups. Okay, so you know if one OH group, that is phenol, if you have OH and CH3, that is called orthocresol. In questions, the common name will be given, IUPAC name will not be given, so make very sure that you learn these structures correctly. Next we have metacresol, okay, and then we have paracresol. Now coming to when you have two OH groups, dihydroxy derivatives of benzene, okay, so when you have OH adjacent to each other, it is called catechol. Okay, adjacent to each other, catechol. Then meta 1 and 3 position, resorcinol, and 1 and 4 position, hydroquinone or quinol. Okay, so catechol, resorcinol and hydroquinol or quinone. Okay, so that is what you have to remember. These structures are very important. Now yes, coming to the nomenclature of ethers. Okay, nomenclature of ethers. So here what you should be knowing, that the common name that we follow is alkoxyalkane. Okay, alkoxyalkane. So if you see here, and what is the common name? You have to tell two alkyl groups and you have to add the word ether. Okay, so if you see CH3, it is dimethyl ether, and the name here is methoxymethane. Then if you see C2H5 diethyl ether, and it is ethoxyethane. Here how will you see? Methyl, and you have CH2CH3, so methyl N-propyl ether and methoxypropane. So whichever is the larger carbon, more number of carbons are there you will use the word propane, means that will be the parent name. Similar, if you see here C6H5 and CH3, right? So here I can write methyl phenyl ether, okay, and that is also called as anisole. But if it is in IUPAC name, you have to write methoxybenzene. Benzene is the bigger group, so that is why. Here what happened? Ethyl phenyl ether, or you can write ethoxybenzene. Now here what is there? 7 carbons on one side and benzene ring on one side. So you see here the number of carbons is more, right? 7 carbon is there, and here only 6 carbons. So parent chain will become heptane. So I can write here first that is your heptyl phenyl ether. This follows alphabetical order. Okay, so heptyl phenyl ether, and I have one more, that is 1-phenoxyheptane. Similarly, here you have CH3 one side, this one, so you have methyl and isopropyl ether, and one other side you can write is methyl, 1-methyl ethyl. Okay, this is 1-methyl ethyl and this is methyl, so it is 2-methoxypropane. I can write this is one carbon chain, So 2-methoxypropane. Similarly, here we have phenol group and you have this one. So I can write like 1, 2, 3, 4. Right? What is this one? Isopentyl group. So phenyl and isopentyl group ether, that you can write. And next one you can write here 1, 2, sorry, you have to number it correctly. Yes. So 1 second. Okay. So we have 1, 2 and 3. I am not selecting the pen. Yes, sorry. Okay, 1, 2 and 3, 4, right? So 3-methyl 1, what is this? This one is your like the parent name is your benzene ring. So 3-methyl butoxy, this whole group is butoxy, 3-methyl butoxy benzene. Okay, next you can see here 1 CH3 group and 1 CH2 CH2O CH3 group, means 2 ether groups are attached. So you can write this is 1, this is 2, 1, 2 dimethoxy ethane. Okay, now here also we have like this, 1 cyclohexyl group is there and 1 C2H5 group is there. So you can name it like 1, 2, or like the substituent should be given less name, right? So 1 and 2. So 1, 1 dimethyl, and you can write 2-ethoxy cyclohexane. Okay, so you can practice these examples in the IUPAC name. Now coming to the structure, so there are 2 important things that you should be knowing about the bond angle. Okay, so in alcohols what happened, the bond angle is slightly less than the tetrahedral angle. That is because the 2 lone pairs that is present, right? So you can see that this is OR and this is H. You have 2 lone pairs here. Now these 2 lone pairs repel each other, they push each other far away from each other. If that is happening, what will happen? This bond will come here, this bond will come here, these 2 will repel, this will come closer, this will come closer. So that is why the bond angle will decrease. How much we are getting? 108.9. Now in case of ether, what happens? You see the bond angle has increased. What is the bond angle for tetrahedral? 109.28 degree. Right? So now what is happening in case of ether? We have 2 bulky groups. Now what happens? These 2 bulky groups also repel with each other. Okay, the lone pairs are no doubt repelling, but these 2 are also repel each other and go far away from each other. So the bond angle increases. Okay. Next, coming to this one, that is your in case of phenol. In case of the phenol is almost equal to tetrahedral angle, but the CO bond length, okay, CO bond length is less than that of the single bond. Why? Because it is involved in resonance. These are the things from where questions can be asked. Next we'll go to next part, that is preparation of alcohols, phenols and its physical properties. Quickly let's go through that. Okay, so what are the methods of preparation of alcohols? I want all of you to make this chart. Okay, this is very, very important. See, so basically we can prepare alcohols first from alkenes, from hydrocarbons, or I can say carbonyl compounds, that is your aldehydes or ketones, then from using Grignard reagent. So under alkenes we have again 2 methods. One is your acid catalyzed hydration and another is hydroboration oxidation. What is the difference here? Let me tell you here. In acid catalyst you follow Markovnikov's rule. In hydroboration oxidation you follow anti-Markovnikov's rule. Now coming to from carbonyl compound, you have reductions of aldehydes and ketones, and you also have reduction of acids and esters. Here the reagent used is NaBH4 and hydrogen palladium. Here the reagent used is lithium aluminium hydride. Quick, we have to revise. Okay, Grignard reagent. How can you prepare Grignard reagent? How can you use Grignard reagent? By reacting them with carbonyl compounds. Okay, so Grignard reagent plus carbonyl compounds, okay, will give you the same thing, alcohols, and what type of alcohols will be produced, that also we will discuss. So let us come first quickly from alkenes. Okay, so if alkenes is there, H plus and H2 you give, then you will get alcohols. Which rule is followed here? Markovnikov's rule. And if you use anti-Markovnikov's rule, that is H2O2 and OH minus BH3 whole 2, this is called hydroboration oxidation, there you will get anti-Markovnikov's rule. I'll give you the example as well. Okay, do not worry. So let us see one example here. Just a minute. Okay, so yes, suppose I have propene. Okay, so CH3 CH double bond CH2, and if you are treating it with H plus H2O and one more reagent you are doing, that is BH3 whole 2 and you are reacting it with H2O2 in presence of OH minus. Okay, so now here what will happen? There is addition of water following Markovnikov's rule. What is the positive part and negative part? We have H plus and we have OH minus. Negative part will go to the carbon having less number of hydrogen. So what will I get here? CH3, CH, OH, CH2H. Clear? Next, coming to hydroboration oxidation reaction, H plus and OH minus, anti-Markovnikov's rule will be followed. So the negative part will go to the carbon having more number of hydrogen. Okay, this is done. So these two are clear. This is how we followed the addition of addition of water. This part is done. Now let us move to from carbonyl compounds, aldehydes and ketones. Okay, so if aldehydes and ketones are there, if you treat hydrogen palladium or NaBH4, you will get alcohol. Basically what you have to do, see again, suppose you have this one, any group which is present. Okay, just if you treat it with either NaBH4 or you treat it with hydrogen palladium, what will happen? This group will get converted to OH, okay, and you will add one H here. Okay, so because two bonds will break, right, one bond will get converted to OH, another bond will get converted to H. Similarly, if you have acid, okay, then you have to use the next strong reagent, that is La, lithium aluminium hydride. We also write it as LaH. Now once this one is done, what will happen? This part full thing gets converted to H. So you keep it one as OH and other two forms HH bond. Okay, so that is what is happening here. Next we can come to acids and esters. So lithium aluminium hydride and hydrogen palladium. Okay, next RMGX. This is very important. So I will tell you all the cases here. So now see, when you have formaldehyde, okay, and you treat it with Grignard reagent, RMGX. Okay, so addition of Grignard reagent is very easy. Only thing you need to know is plus and minus. So for example, this is plus, this is minus, this is minus, this is plus, right, based on their electronegativity and positivity. So when you take this one, what will happen? R minus will attack here, O will attack here. So what will I get? H, C, O, M, G, X, okay, then this side R and this side H. So now what will happen? If I treat it with hydrolysis, just you do H3O plus. So what you will get? H, C, OH, H and R. Okay, so this is what? Primary alcohols. Okay, you can see the carbon which contains the OH group is attached to only one carbon. This is primary. Now if I want, if I take any other aldehyde, okay, okay, if I take any other aldehyde and I add RMGX, okay, the same thing will happen. R will attach here, OMGX, then it will get converted to OH. So I am directly writing the product OH, H and this side R. So now see, this carbon which contains the OH group is attached to two other carbons. So this is what? Secondary alcohol. Now if I take a ketone group, okay, and you take RMGX, okay, now again this one will attack here, OMGX, that will get converted to OH. So I have CH3, C, OH, CH3 and R, right. So what is happening here? This one will give you a tertiary alcohol, right. So this is forming a tertiary alcohol. So what did we learn? If you are adding Grignard reagent to only formaldehyde, then you will get primary alcohol. If you are adding it to if you are adding it to any other aldehyde other than formaldehyde, you will get secondary alcohol. If you are adding it to a ketone, you will get tertiary alcohol. Okay, that is the whole story of the Grignard reagent. We are done with this. We have discussed all the methods of preparation. I hope that you have remembered this all. Okay, and I want all of you to prepare this flow chart. So in this, suppose you have started your note making in one A4 sheet. On the starting, the half of A4 sheet, these all things can be written. Okay, next, moving forward, we'll go to preparation of phenols. Okay, so preparation of phenols are little, I'll say, like little difficult and new reactions are there. The first one is from haloarenes, then you have from benzene sulfonic acid, from disonium salt, and from cumene. This from cumene is very important. Many a times it is asked in your PU board exam as well as in your KCET exam. This particular mechanism is very important. Okay. So let us see, if I want to prepare from haloarenes, okay. So you have to take NaOH at a very high temperature and pressure. So what will happen, this OH minus will attack here, Cl minus will go, and we will get this phenol, okay, which is not a very easy reaction, okay. So that is the first method. The second one is from sulfonic acid. So this, you take benzene, you treat it with concentrated sulfuric acid, you will get, this is called as benzene sulfonic acid. Then you treat it with NaOH and H+, you will get converted to phenol. This is also not a very important method, okay. Now if you come to Grignard from benzene disonium chloride, this is important method, NH2, convert it into benzene disonium chloride. Once benzene disonium chloride you get, just warm it with water, you will get OH. Yes, the next one which is actually important is this one, this structure, okay, this is called as isopropyl benzene. Please remember these names, questions have been asked repeatedly from here. So isopropyl benzene, or it is also called as cumene, okay. Once you add OO, what happens, this group here OH is added, you can see. Now if you take H plus and H2O, what will happen, this one get converted, and you also remember the byproduct here, you will get phenol plus acetone, okay. Remember what is acetone, CH3 CO CH3, clear. So 4 methods of preparation of this one, phenols. Now coming to physical property, very simple thing, talking about boiling point. If mass will increase, boiling point will increase, that is there. And the boiling point is also high for alcohols due to the hydrogen bonding, and the boiling point will decrease with the increase in branching. So this is very common to your hydrocarbon chapter, sorry, your haloalkanes chapter, so nothing new. More is the mass, more is the boiling point, more is the branching, less is the boiling point. And they have generally high boiling points due to the formation of hydrogen bonding. Now coming to the solubility, they are soluble in water due to hydrogen bonding, again very important. Next, the solubility will decrease as the size will increase, okay. Fine. Now let us do one small question here, okay, just to boost up what we have studied till now. So first is CH3CHO plus 1 MgBr is added. So what will happen, you can see this is one aldehyde, right. So if I add to aldehyde, I will get a secondary alcohol. What I am adding, CH3 MgBr, okay. So this one will attack here, this one will attack here, so I will get CH3, just no need to do, just convert it, just make it OH, and this add one H and CH3, okay, I got a secondary alcohol. Then concentrated sulfuric acid and heat, you know this is what, dehydrating agent, one OH group will be removed, so I will get CH3 CH double bond CH2. Next, after once you get Q, you take B2H6 H2O2 OH minus. What does this do? This adds water following anti-Markovnikov's rule. I hope all of you remember, just now we discussed. So what will I get? CH3 CH H double bond CH2OH. So what is the relation between, question is asking P and R. Where is my P? This is P and this is Q and this is R. So P and R, you can see OH is on the second carbon, OH is on the first carbon. So what is it? It is position isomers, okay. This was a PYQ of KCET. Okay, let's solve one more question. You have been added to one aldehyde, you are adding this one, okay, the same thing. So you first see, this is H. So what will happen? This one will get converted to OH, okay, and this CH3 will be added here, okay. So this is the compound that I am forming. Okay, so first it will form OMgBr, okay, then when you do hydrolysis you will get OH. So what is the IUPAC name of this one? 1, 2, 3 and 4. So I can write 3-methyl, so butane 2-OL, option number A, okay. How easy is that? Fine. One more question last, let us go, ethanol to PCl5, okay. So what is this? Conversion of alcohols to alkanes, right, sorry, haloalkane. So if I will get C2H5Cl, okay, then alcoholic KOH, there will be elimination, I will get C2H4, okay. After that you are adding H2SO4, room temperature, water and heat. Okay. Okay, so once you are adding this one, acidic water you are adding, right? At room temperature adding acidic water, so that will give you OH group. So you will get CH3, CH2, OH, option number D. Okay, that is the thing. Now let us move to the next part, that is the chemical reactions, very very important. So first of all, okay, now see, chemical reactions of alcohols are of two types. I'll explain what is this. Now see, alcohol can behave both as an electrophile and a nucleophile. What do you mean by that? That means it can act as an electron deficient species. It can also act as an electron rich species. Okay, so electrophile means electron deficient species, and this electron nucleophile means electron rich species. Okay, now how does that happen? See, if this oxygen is having lone pair, right? So if something is there, one electrophile is there, this lone pair is attacking on that electrophile, then it is behaving as a nucleophile. It is attacking on an electrophile, it has this lone pair, it is using this lone pair, so it is a nucleophile. Okay, now suppose what happens, there is ROH, okay, there is ROH, and somewhere in the medium H plus is also present. Okay, H plus is present. You know this one is a nucleophile. Oxygen lone pairs are super active, hyperactive. What will they do? They will take this H plus. So what I will get? RO plus H2. Now once this RO plus H2 is formed, water is formed. Water is very stable compound. What this water molecule will say? Tata bye bye to the R group. So what will happen? This ROH plus 2 will leave and I'll get R plus. Now this R plus is a what? Now this R plus has become a electron deficient group, or I can say in this case it can behave as an electrophile. Okay, so what is the conclusion? ROH, okay, can behave as a nucleophile by donating its H plus, by using its lone pair. Okay, suppose H plus is also taken from this ROH, so what it will form? RO minus. This is also nucleophile. Okay, so basically it can react in this way or using the lone pair. Electrophile. If it found some H plus in between, somewhere H plus is there, then immediately what will happen? Water will form, water will go out, and this one will become an electrophile. Okay, so that is why it can behave in both the way. Okay, so you can see how it is behaving as a nucleophile. The lone pair of R is, the lone pair of oxygen is attack on any type of any type of carbocation or electron deficient species. Where have you seen this reaction? You remember SN1 mechanism. In SN1 what? First carbocation forms, then one OH minus or nucleophile group can attack. That can be your OH group. Okay, so that is as a nucleophile. As electrophile, as I told you, first what happens? There is protonation. This water molecule forms. It says Tata bye bye to CH2 group. This group leaves. Okay, or you can just imagine any nucleophile comes, attacks on this one, and this one is ready to leave. So in that case, because this O plus H2 is formed, this is a delta electrophilic center now, because it will pull electrons more. So that is why this becomes a delta positive center or a electrophilic center on which the nucleophile can attack. I hope that you have understood this one. This should be very very clear. Okay, so now if I talk about, okay, one second. Okay, so see, if this alcohol is behaving as a nucleophile, okay, I told you if it is behaving as a nucleophile, this bond will break, RO minus will form. Okay, so the reactions that are taken by RO minus is that case where ROH behaves as a nucleophile. And if it is a electrophile, what will happen? You remember, O plus H2 will form, then Br minus, some Br minus can attack or any nucleophile can attack. So there is the cleavage of CO bond and here is the cleavage of OH bond. So based on that we have two types of reaction. So let me clarify here. When there is cleavage of OH bond, what is the reaction? ROH behaves as what? Nucleophile. When there is cleavage of CO bond, what is there? ROH behaves as one second. ROH behaves as nucleophile. Here it will behave as electrophile. Okay, so let us see next. So and in this category we have three reactions: reactions with metal, acidity of alcohols, and esterification. Under cleavage of CO bond we have again three types of reaction. One second. Yes. Reaction involving or reactions with HX, reactions with PX3, dehydration, and you have oxidation reaction. Okay, so please keep this picture in mind. Okay, this picture is very, very important. Let me revise you. You have two types of reactions. Okay, ROH is a dual character, double personality. It can react as an electrophile, it can react as a nucleophile. If it is behaving as a nucleophile, then OH bond will cleave. Okay, behaving as a nucleophile means O minus, you remember O minus is there, so OH bond has to cleave. So now where can this O minus bond attack? It can attack on any metals. Okay, it can behave as an, because it is donating H plus, right? So it can behave as an acid, and it can react as an esterification. Okay, reaction with metals, acidity and esterification. Now suppose the OH group is getting protonated. Okay, so any nucleophile can attack on R group. Okay, so what all reactions it can show? In that case it can behave with HX, so this X will attack on this R group. It can react with PX3, again X is there. Dehydration, it can water loss of water can take place, dehydration can take place, and oxidation can also take place. Okay, so four types of reaction in that: reaction with HX, reaction with PX3, dehydration, and oxidation. Okay, fine. So now coming to the first one where there is cleavage of OH bond. So you have first one, that is reactions with metal. Here it will give H plus, O minus will form, O minus will react with Na plus, so RONA plus H2. Okay, this is done. Now the reaction, this is the first one, that is reaction with metal. Okay, next what we have after the reaction with metal, once this is done, next one is your esterification reaction. Acidity I will discuss, but next one is esterification. So esterification can happen when alcohol reacts with any of these three: acid anhydride, or acid chloride. So basically what you have to do, you have to keep this RO and take this R dash. So RO, you have to this H, okay, and this OH you have to remove, and rest things should join. So you have R dash CO OR. Okay, this is one form. Next you have this one, here also same thing, just you have to join this R dash CO, and here also R dash CO. Okay, this part is there. Clear? R dash CO OR. That is how the esterification reaction will take place. I'll give you one example. So for example, see, suppose I have CH3OH. Okay, I'm reacting it with all three. Okay, so first one is, okay, let me not do like this. One second. Okay, see, suppose it is reacting with one acid group. Let me write R dash. So what will happen? This one will be lost. So what I will get here? CH3, okay, CH3O, C double bond O, R dash. Ester formation has happened. Next, you can also react it with anhydride. What is anhydride? See, anhydride is basically like this. You have CH3, C double bond O, O, C double bond O, CH3. Now what happens? This one will behave as a what? Lone pair, right? Nucleophile. I told you nucleophile. Nucleophile can attack on this one. This bond will shift. This bond will break. So what I have? CH3, okay, O, CO, CH3. Now coming to next one, if I have alcohol, okay, and you are reacting it with, this is your acid, this is anhydride, acid chloride, right? So I'll write like this. So what is happening? HCl will go, and rest part we have to connect. I missed one oxygen here. So you can see that all these three compounds can react with alcohol to give you esters. Okay, and one more important thing, you can see that RO minus is basically reacting here. H means it is behaving as a nucleophile. Okay, fine. So that is there. Okay. Next is reactions of alcohols where there is cleavage of CO bond. Okay, under that, what was the first reaction? Reaction with HX. So where we can see, yes, reaction of HX. So very simple, what happens? The mechanism is very simple here. ROH is there, right? And you are reacting it with HX. I told you whenever this H plus will be available, this will get protonated. Okay, so we have like this one. Now this X minus is present, X minus can attack here, this one will go out and you will get RX. Okay, now this reagent, okay, or this, one second, yes, so this is the first one. Now here one special reagent is used, that is Lucas test, where you take HCl, okay, in presence of ZnCl2. Now in this case what happens, you see carbocation formation is taking place, right? So if there is carbocation formation, then the mechanism must be SN1 reaction. Okay, so this is what basically you can think that OH is replaced with X, substitution reaction is happening. What type of substitution reaction? SN1, because there is a formation of carbocation, and we know what is the order of SN1 reaction: 3 degree, 2 degree, 1 degree. So the same thing happens here. Tertiary alcohols reacts faster, okay, and they produce turbidity. Secondary alcohols react within 5 minutes, okay, and primary alcohols do not react easily. Clear? Fine. So next is your PX3. This we have already studied in the preparation of haloalkanes. OH will be replaced with X, so we will get RX. Okay. The third one was your dehydration. So if you take H2SO4 and heat it at 443 Kelvin, or if you use H3PO4, what will happen? Dehydration will take place and we will get an alkene group. Okay, so dehydration reaction will give you alkene group, and the order of dehydration is again 3 degree, 2 degree and 1 degree. Okay, so we had how many reactions in this case? 1 second. Yes, oxidation, 4 types of reactions were there, right? Reactions with HX, PX3, dehydration is there. Now we'll go to oxidation reaction. So oxidation reaction, what is happening? Your primary alcohols will get converted to aldehydes, secondary alcohols will get converted to ketones, tertiary alcohols will not react. Okay, remember, primary to aldehydes, secondary to ketones, tertiary no react. What are the oxidizing agents here? So you can use CrO3 or PCC. Okay, so in CrO3 what happens? Primary alcohols gets converted to aldehyde, secondary gets converted to ketone. Now similarly, primary alcohol can get converted to CHO using PCC. Okay, now so what is the cycle of oxidation? See, our alcohols gets converted to aldehydes on mild oxidation, okay, primary alcohols, and it can get converted to acids on strong oxidation. Okay, so for mild oxidation you can use CrO3 or you can use PCC, but for strong oxidation you can use KMnO4 or K2Cr2O7. Clear? This is done. Now coming to copper at 573 Kelvin. So what happens? It converts primary alcohols to aldehydes, secondary alcohols to ketones and tertiary alcohols to alkenes. Okay, primary to aldehyde, secondary to ketones, tertiary alcohols to alkenes. Okay, copper at 573 Kelvin. Okay, so this is all about the chemical reactions of alcohols. So let us have a brief discussion. Whatever we have studied, I will revise it quickly. You should also revise with me quickly. See, I have alcohol, 2 types of reactions. One is where there is cleavage of OH bond, and one there is where there is cleavage of where there is cleavage of RO bond. Here when this type of reaction is taking place, it is behaving as a nucleophile. When this type of reaction is taking place, it is behaving as an electrophile. Here what all reactions are there? The first reaction I have is reactions with metals. Next it can have the acidic behavior, okay, about which we have to discuss in detail. And then we have something here is, what is that? Esterification reaction. Okay, so this is the reaction where it is behaving as an nucleophile. Now coming to electrophile, what all reactions we have? in electrophile, the first one is its reaction with HX. Here you should be knowing about Lucas reagent. Okay. Next, the reaction is with PX3. Okay, this is simple reaction we have already studied. Next, the reaction is your dehydration. Okay. And next one is oxidation. Under oxidation, what all reagents we have studied? We have studied about I can say CrO3. We have studied about PCC. We studied about copper at 573 Kelvin, and we studied about KMnO4 and K2Cr2O7. So you see the complete reactions I can just write down like this. Okay, so that is how you have to do your flowcharts, your short notes. Okay. Now moving towards the reactions of phenols. Okay, so phenols we have very simple reactions. Okay, sorry, one second. Okay, fine. So phenols, what is the most of the reactions are already known to you. Acidic nature of phenol I will discuss in detail. Esterification, just now how we have just esterification in alcohol, same esterification reaction for phenols as well. Next, electrophilic substitution. Phenol itself is a nucleophile because OH can donate electron. It is a activating group, so it will react with electrophiles. What all electrophile can act? Nitration and halogenation. Next, we have Coles reaction. This is important, a name reaction. Rimmer-Timon reaction. These two reactions are important. Reaction with zinc dust, I think many of you would have remembered by now. This will give you benzene. And oxidation. Oxidation of phenol will give you quinone. Okay. Let us see quickly now. First comes the reactions of phenols. So the first reaction I want to discuss is your reactions with metals. Okay. One second, let me go through it step by step. Okay, so first of all, phenol has this acidic nature, right? This O minus can attack here. So these are the two reactions which shows the acidic nature of phenol. Okay, these two reactions shows the, I told you, acidic nature, right? How can you prove that phenol is acidic in nature? So anything which is acid, it reacts with metals. Okay, if anything is acid, it will react with a base. So that is why this one reacts with Na to give you ONA and H2. This one reacts with NaOH to give you ONA plus water, that is salt plus water. Acidic nature is over. Then what were the reactions we studied after that? Esterification. Okay, esterification, I told you, it is similar to what we have already studied in alcohols. Okay, just I'll give you one example for esterification. Suppose I have like this OH. Okay, right? So what will happen? H and OH will be removed and I will get O. That's esterification. Okay, so esterification over. One second. Yes, so esterification over. This is the second reaction, acidic nature over. Okay, next we have electrophilic substitution reaction. So electrophilic substitution, under that we have two things, nitration and halogenation. So for nitration, if you use concentrated HNO3, OH group is a highly activating group. It can donate its electrons. So these are the positions from where ortho-para directing group, it is a electron donating group, ortho-para directing group. So what will happen? NO2 will be present in all the three positions, ortho-para positions. All the three are occupied, and this compound is called as your picric acid, which is highly acidic in nature. Now, but if you just want any one product, so you will take dilute HNO3. In that case, what will happen? Ortho and para products will be given or produced separately. Okay. So this is your third reaction, which is your electrophilic substitution reaction. Okay, now coming to the next one, halogenation. So similarly, if you just treat it with bromine water, what will happen? All the positions will be occupied because it is a highly activating group. Now if I just want that, I want ortho and para products separately, then you have to use bromine with CS2. Okay, so that is under halogenation. Next, what we have, next one is your, this is your third reaction. Next one is your Coles reaction. Okay, this is your Coles reaction, where first you treat it with NaOH, so you get a salt O minus Na plus. Then you treat it with CO2. So what will happen? O minus will form here, and you get a COOH group. Okay, and this is called as salicylic acid. this compound is formed. OH and COOH is formed. That is what? Cole's reaction. Number 4th. 5th reaction is what? We have the 5th reaction here, Reimer-Tiemann reaction. 5th reaction is Reimer-Tiemann reaction. Okay, so what happens? First CHCl3 is taken, you get CHCl2 is I'll say placed here, then NaOH, then you get CHO. The final product here is salicylic aldehyde. Okay, so this is your Cole's reaction. Okay, so this is 5th reaction. Next, 6th one is what? 6th one is reaction with zinc dust, that will give you benzene, and the 7th one is your oxidation, which will give you Na2Cr2O7 with H2SO4, and this product is called as quinone. Clear? So now let me see quickly the chemical reactions of phenols. Okay, I'll write it separately for you. I remembered the first reaction was what? I am also trying to recall, you also try to recall, esterification. Okay, esterification, very easy, I have remembered what is there. Next one was acidic nature. We will talk more also about acidic nature, but which two reactions told me about the reaction, about the acidic nature? Reaction with Na and reaction with NaOH. Now the third one is your electrophilic substitution reaction. Okay, in that I have two things, nitration and I have halogenation. So I am making short notes. Okay, I won't write the full words. So for nitration, again I have two things. I should know that if I use dilute HNO3, what will happen? There will be separate products. If I use concentrated HNO3, there will be all the substituents will be there at that same time. Here also I have know what is bromine and what is Br2 and CS2, right? Next, coming to the 4th reaction is my Cole's reaction. This is a name reaction, so I should remember this one. So what is used here? It is first is treated with NaOH, then it is treated with CO2. Next, 5th one is your Reimer-Tiemann reaction. I'll just write like this, Reimer-Tiemann reaction. Here I am treating it with CHCl3, then I am treating it with NaOH, and then I am doing hydrolysis. Okay. Next, 6th one is the treatment it with zinc dust. Okay. Next, 7th one is your K2Cr2O7, which gives me, here it gives me benzene and here it gives me quinol. Okay, that's the overall reactions of phenols. Clear? Fine. Next, moving to the next topic, that is esterification. I have already explained. Okay, so how can you do with alcohol, with acids, with anhydrates, with acidic anhydrates? There is one very important esterification reaction, from which one is important, from this salicylic acid. Okay, if you treat it with CH3CO, that is anhydrate group, what happens? Here we get OCOCH3. Okay, and this product structure you should remember, because it can be asked what is the structure of aspirin. So this is the structure of aspirin, which is widely used in medicines. Okay. Next, we'll talk about the acidic nature of alcohols and phenols. Very, very important. So now see. Okay. So acidic nature of phenols means what? What I'll say, tendency to donate H plus, or it can be determined by the stability of conjugate base. Now see, suppose one acid is, one HA is there, okay, it will donate H plus and this A minus will form. This A minus is called as conjugate base. So if A minus is very stable, okay, the acid will be very strong acid. Okay, so now what happens? See, suppose you have one acid, I'll take two alcohols example. You have here CH3, CH2OH and CF3, CH2OH. It will release one H plus. So what I'll get here? CH3, CH2O minus. This one will release, I'll get CF3, CH2O minus. Right? So what does this tell me? Now see, this part, this negative, this conjugate base, this is a negative charge, less is the negative charge, more is the stability. Okay, so to reduce the charge, what do we need? Electron withdrawing groups. So here you see CH3 group is there, here it is CF3 group, which is more electro withdrawing. So that is why what will happen, this one will be more acidic. Why? Because this one will withdraw more electrons, this one will be more stable, right? If the stability of conjugate base is more, then strongest acidity will be more strong. Clear? This is understood? Okay, now moving forward to, so what I learned here, electron withdrawing group will increase the acidity. Okay, that's all. And that by default, that also tells me that electron donating group will decrease the acidity. Right? Okay. Now moving forward, if I do it with phenols, okay, you have okay, and I have this NO2 group. Same, this one will be more acidic because it is electron withdrawing group. Now if I have one more like this, this is electron withdrawing group. Now suppose I have OH and I have NO2 meta position, and then I have OH and I have NO2 in the para position. Okay, so here it is meta position and here it is para position. Then what will happen? See, para position NO2 group will be more efficient. Why? Because if you draw the resonating structure, you can say that NO2, if it is in para position or in ortho position, it can actually take the negative charge. Okay, so that is why NO2 group in para and ortho position will be more effective. Okay, so you should remember electron withdrawing group should be present at ortho and para position, ortho or para position. Okay, then the acidity will be more. Okay, this is the concept. If this is known, you can solve any question. Okay, moving forward to part 4, where we are discussing about commercial alcohols and the ethers. So under commercial alcohols, I have two alcohols to discuss, that is methanol and ethanol. Okay, and ethers, we will be studying their preparation of ethers, their physical properties and their chemical properties. Quickly we'll finish, this is a very small topic. Okay, so coming to methanol, what you should be knowing, what is the commercial name of methanol? That is wood spirit. Why? Because it is obtained from destructive distillation of wood. Okay, now how it is prepared? You take carbon monoxide with hydrogen, under this particular reagent you will get methanol. Okay, carbon monoxide, hydrogen, under ZNO and Cr2O3, these conditions no need to remember, it will give you methanol. And what other things you should be knowing about its properties and all, not very important. These are the two things that you should be knowing about methanol. Next, coming to ethanol, this is very important. From here questions have been asked repeatedly. So how is ethanol actually prepared? Ethanol is prepared from the fermentation of glucose. Okay, fermentation of glucose. Now how to derive this glucose? From where will we get glucose? Because in nature glucose is not available directly in abundant quantity. So what happens? You take sucrose. Okay, we take sucrose, hydrolyze it in presence of which enzyme? Invertase. It will give you glucose and fructose. Now once this glucose is produced, this glucose can be fermented using the zymase enzyme to give you alcohols and carbon dioxide. Okay, so that is there. Okay, next we have ethers. What is the preparation of ethers? We have two methods. Yes, so one is your dehydration of alcohols. So this is, I think most of you should be knowing that yes, alcohols, okay, if you dehydrate them, that means in presence of concentrated H2SO4 at 443 Kelvin, you will get alkene. Okay, but if you dehydrate them at 413 Kelvin, then we call it, or then we get ether. So we are going to use that dehydration of alcohol at a lower temperature, that is 413 Kelvin, to get alcohols. Okay, and the very famous and most important method is your Williamson ether synthesis. So here what happens? See, here you react 1 Rx plus R-ONA. Okay, so what is Rx? Rx is your haloalkane, R-ONA is your alkoxide ion. Alkoxide ion, and you have haloalkane. Okay, if these two are reacting, this is what? Delta minus, this is delta plus, this is delta minus, and this is delta plus. So now what will happen? This O minus will attack on this R. Okay, so you will get R-OR. Okay, and you will get NaX. That is the formation of ether. This looks very simple, but here there is a catch that you should remember. This R-X, I'll write it in very important. R-X must be a primary halide. Okay, very, very important. If this is not happening, so this reaction exactly what is happening? See, this X group is substituted with OR dash group. So basically what is the reaction happening? Substitution reaction. But if this is a tertiary halide group, then what will happen? Elimination will happen and we will get alkene as the major product. Okay, let me explain to you in detail. I'll take two cases. Okay, so I have one this CH3Cl, okay, and I'm taking CH3O minus Na plus, or wait, one second, I will take O minus Na plus CH3. Okay, so now what is happening? This O minus, this is minus plus, here this is minus, this is plus, O minus will attack on plus, this one will form bond. So what is the product I will be getting? CH3, CH3, CH3. Here what is happening? O is there, this O is attacking this CH3. That is the product that is formed. Now if I just reverse this one, means if I take like this, okay, CCC, and here I take Cl, okay, and I'm just mentioning CH2H, okay, and I have this one as CH3O minus and Na plus. So here this is behaving as a nucleophile, but in this case what will happen? This will behave as a base, and what it will abstract? It will abstract this hydrogen, this bond will shift here, this bond will break. So what I'll get a product here is, I'll get this one and this one. Clear? So what exactly is happening here? If you take this tertiary alkyl halides, then you will end up in getting a alkene. And why that is happening? Because here the process that is dominating is elimination, and the process that is dominating here is substitution. Clear? Okay, fine. So that is what you should be remembering in preparation of ethers. Okay, so I have discussed this one in detail. Okay, now coming to the physical properties, nothing much is important here. The CO bonds in ethers are polar and thus have a net dipole moment. So that is there, and they are soluble in water because the oxygen of the ether can also form hydrogen bond with water molecule. So if you see, ether is like this, right, and it has two lone pair, and we have water molecule, okay, which can form a hydrogen bond here, and we have water molecule which can form hydrogen bond. Okay, fine. Next, moving forward, you have the chemical properties of ethers. Okay, so I'll show you. Okay, this is very, very important chemical property of ether, where there is cleavage of this CO bond. Means you have R, O, R, right? So this bond has to cleave. Okay, that is called cleavage of CO bond. Now here which mechanism is followed, which one will take place, this is very, very important and critical. In electrophilic substitution, very easy, you have halogenation, nitration and Friedel-Crafts reaction. Okay, this we have already been very familiar, so that is not going to be much difficult, but yes, this is something which is very difficult and it is important as well. So now see what exactly happens. You have a ether R1O and R2. Okay, now HX is there. So what will happen? First, we know this lone pair of oxygen are hyperactive. Wherever it finds H, it binds to that, it forms this O plus H. Now there is one X minus, right? So this X minus can attack here, okay, or it can attack here. So you can, if this X minus attacks here, then we can also have a product like this R1X. This one will attack here, okay. So this X minus is there, okay. This one will attack here. You will get R1X, and now what will happen? After this is formed, and you will get R2OH. This is one possibility. Or this X minus can also attack on this one, and you will get R2X and R1OH is formed. Okay, so these are the two possibilities. So how to decide which one will attack where? Very, very important. Listen carefully. Now see, if both R1 and R2, okay, if R1 and R2 are both primary and secondary, okay, it is either this one is primary, this one is secondary, or both are secondary, or both are primary. Any possibility. Primary, 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 secondary, secondary, primary, secondary, secondary. Any of this possibility is there. And reaction is happening with HX. The mechanism followed is SN2 mechanism. In that case, what do you mean by SN2 mechanism? If it is SN2 mechanism, then what will happen? The X minus, okay, the X minus will attack on the less hindered side. It will attack on less hindered side. Okay, it can either attack here or it can attack here. Like for example, if I give you CH3O C2H5, okay, and you are reacting it with HX. Now see, this one is less hindered, okay, this one is less hindered, so the X minus will attack on the less hindered side. So I will get CH3X plus C2H5OH. SN2, right? Less hindered side, X, this one O plus H will form first, okay, X will attack here, so CH3X will form, this bond will break, and I will get this one. Okay, that is there. Now next thing, what is there? If any one is tertiary, okay, if any one is tertiary, then or it is a resonance stabilized carbocation is forming, then SN1 method will follow. That means, for example, if I have like this side it is tertiary and this side it is primary, then it will always be like this. The bond will break here and the carbocation will form here. Now the carbocation will take the negative part, right? So here there will be X and here it will bond with H. So whenever you find one side it is a stable carbocation is being formed, then SN1 mechanism will be followed, and the SN1 mechanism will be followed, and the one which is getting forming carbocation will bind to X. Okay, let me see if I can give you some examples for this one. Yes, so let us see this one. OH is there, right? I can find this is a tertiary group, right? Here the bond will break, carbocation will form here, plus will take minus. So the product formed here is CH3OH plus I have C, Me, Me, Me and I. Okay. Next, phenol group is there. Okay, you can find this phenol group is here. So what will happen? Whenever there is phenol group, this bond will never break. Phenol and carbon and oxygen bond will never break because it is very, very stable. So what will happen? This bond will break and this one will take OH. So I will get phenol here. Okay, and the product formed is CH3I. Now you can see here, if I get this is primary group and this is secondary group, right? So definitely this is more hindered, this is less hindered. So I will attack here and H will attack here. So I will get here cyclohexanol, okay, plus CH3I. Clear? So you have to check if any stable carbocation is formed, then SN1. Other than that, if phenol is there, then PHO bond will not break. Other than that, you have to check wherever less hindered side is there, there I will go and attack. Okay, this is very important. Now coming to the electrophilic substitution reaction, very simple. This is your what? Anisole. Okay, this is called as anisole. Please remember, OCH3 group attached to benzene ring is called as anisole, and it is an electron donating group. If it is electron donating group, it will be ortho para directing. So if I am giving bromine with CH3COH, what will be the product here? You will get OCH3 at ortho position, you will get bromine, and here it will be OCH3, and at para position you will be getting bromine. Next, if you have RCOCl and AlCl3, this is again a donating group, so again ortho para substitution will take place. So you will get here OCH3 and here it will be COR, okay, and I'll get OCH3 and here it will be COR. Clear? Now coming to if I have RCl and AlCl3, this is your Friedel-Crafts alkylation. The same thing, I have OCH3, so R will be attached at ortho position, and I have OCH3 and R will be attacked at para position. Now concentrated HNO3 and H2SO4 will do nitration. So you have here OCH3 and ortho position nitro group will be present, and here you have OCH3 and para position nitro group will be there. Okay, that is your electrophilic substitution reaction. Very simple one. Already you know these reactions. Let us see a small question on the acidic strength. You have metanitrophenol, metacresol and phenol. Okay, so if I draw this structure, okay, this is phenol, you have metanitrophenol, okay, you have cresol. What is it? Metacresol. Okay, then you have phenol. Okay, so now see, this is an electron donating group, this is a withdrawing group. So we know that electron withdrawing group will increase the acidity. So that definitely first one will be more acidic, and this is a donating group, it will decrease the acidity, so 2 will be least acidic. So I have only 2 options where 2 is least acidic, or there are 3 options, and 1 should be more acidic. So I have only 2 options where 2 is least and 1 is, okay, there is one more compound, I am wrong here, I think 2 and 1 will see, okay, 4 you ignore. So basically between 2 and 1 what will come? 3 will come. Okay, so what is the structure here? 2 is least acidic, then 3 is least more acidic, then first one is highly acidic. Okay, next coming to, okay, so that's all students. In this class we have discussed all the properties, all the reactions, and I hope that you would have also drawn the flow charts with me. Okay, so I'm telling you, please follow this series. This is going to be your game changing series where you can cover the entire concept, revise everything, and you can join us live and solve questions also. Okay, so that's all students in this class. I hope that this will help you, and if you have any doubt in any concept, do not forget to comment down. I'll definitely address it. So thank you for watching, and thank you for showing so much love to this series and all, and I hope that you continue. All the very best for your preparation, and see you soon in the next episode. Till then, take care.